welcome to the Science Pundit channel. I hope you are having a good day. Anyway, let's go straight to the point. Today we are going to be talking about the Harber process. The Harber process is the manufacturing of ammonia. This comes under the industrial processes in chemistry. It can be in science or any other subject that you are doing. Alright, so here we are manufacturing ammonia, and the main raw materials for this process, that's nitrogen and hydrogen. Right, nitrogen and hydrogen, we are getting our ammonia, NH3. Right, the reason why I put this sign is to show you that this is a reversible reaction. This is a reversible reaction, right? So we're saying that when you're doing the Harber process, it is in stages. The first stage is having nitrogen and hydrogen. Nitrogen is obtained from the liquefaction of air. If you liquefy and then fractionally distillate the air that we breathe, the normal air which is surrounding us, it is compressed, liquefied, and then it is then fractional distillated, and then we can have what? Our nitrogen. As for the hydrogen, hydrogen is obtained from electrolysis of acidified water. We can get hydrogen coming to the cathode, and then we've got our ammonia there. So we say that the first stage is to highlight that nitrogen and hydrogen is mixed in the ratio 1:3. 1:3 is the ratio that you use. 1 unit, 1 mole of nitrogen is reacted with 3 moles of hydrogen to get how many moles of ammonia. Right, so to balance this equation, we've got 2 nitrogen atoms here, so we are simply going to put a 2 there. So we're saying N2 plus 3H2 to give us 2NH3. Right, so the conditions of this equation is an exothermic reaction. This equation is an exothermic reaction, right? And also it is a reversible reaction. It is a reversible reaction. So another thing which is important in this case is we have to raise the pressure to 200 atmospheres. 200 atmospheres. Why? Because here on the left hand side we've got 1 plus 3, which is 4 moles, and here we've got only 2 moles. So if we raise pressure, we are saying that we are going to have our equilibrium shifting to the right hand side, producing more ammonia. Right, so if we increase the pressure, we are guaranteed to more products of NH3 being produced. Then we are also going to use an ion catalyst. Ion is not taking part in this reaction, but it is working as a catalyst. It is providing more surface area and acting as a catalyst. Right, so another condition that you need to state here is you are going to have a temperature of around 450 degrees Celsius. It can be 450 to 500, but mainly we prefer 450 degrees Celsius. Someone might wonder, why is it this process is exothermic, meaning that if we raise our temperature, we are going to have a backward reaction. So in this case, if we do not raise the temperature, the process is going to become slow. Hence, we are going to provide more temperature to make sure that we have the activation energy as soon as possible, and also that the process is economic. Because mostly when we are making ammonia, we are making ammonia for use. Like ammonia is used in many purposes, like making of fertilizers, making of soaps, detergents, and many other things. So if we now use a slow temperature, therefore we're also going to have our reaction proceeding very slowly. So it is advised that when you produce your ammonia, you're supposed to remove the ammonia in the system so that the equation will continue shifting the equilibrium to the right hand side. So basically, this is what you need to know. Firstly, when you're asked to describe the Harber process is the manufacturing of ammonia, and then we're saying ammonia is mixed with hydrogen in the ratio of 1:3. In the ratio of 1 H2 and then the temperature is 450 degrees Celsius. An ion catalyst is used, and